Good afternoon, ladies and gentlemen. First off, I'd like to welcome you to our first digital technical meeting. It's been a challenging period for the industry, the country, and globally. So we're looking at the positive takeout from this in the sense that we now are able to reach a wider audience. And that obviously is what we stand for knowledge transfer and sharing information. So we are grateful that we are forced, in a sense, to explore these new technologies to allow us to have this technical meeting. To start with, I'd like to mention the passing of Dave Peatfield. He's been a past Coal Person of the Year in 2009 and a past chairperson of the SACPS from in 1990 to 1991. So we're very saddened by the loss of Dave, and he's contributed significantly to the coal industry within South Africa and internationally as well. I'd also like to welcome Rufilwe Maila as the new vice chairperson. She will be taking over the chairpersonship from next year's AGM. So Rufilwe, we wish you luck in your new role from next year, and we know that we will be impressed by your leadership and your chairpersonship of the SACPS. And finally, I'd like to congratulate Peter Hand as the Coal Person of the Year 2020. To most of you, I don't need to mention Peter Hand. I think he's well known within the industry. He's been a valuable contributor to the coal industry and the Southern African Coal Processing Society. So congratulations, Peter, on the award of Coal Person of the Year 2020. So I won't delay any further. I'm going to hand you over to Jason, and we're going to be listening through to the presentation by Sipho.
Good afternoon, ladies and gentlemen. Welcome to our first ever online live technical presentation. It is my absolute honor to introduce Sipho Sikhosana to you this afternoon. I think before I continue, I would like to say thank you very much to Sipho and thank you very much to Exxaro for allowing this presentation to happen. Perhaps a short bio of Sipho before he gets into the business end of today. Sipho Gerald Sikhosana developed an early interest in metallurgical processes, for he grew up in Mpumalanga, a coal mining region. With a background from eMalahleni, his curiosity led him to pursue a metallurgy and material science degree and coal science graduate diploma in engineering from both from Wits University. After graduation, he went back to Mpumalanga to work on the coal mines. He fulfilled various metallurgical on-site roles before he joined the corporate world as a coal process engineering specialist. In parallel, he completed management development program and program in engineering management with University of Pretoria. During his employment with a few coal mining companies, he obtained his professional engineering status with the Engineering Council of South Africa, to which he is the current accreditation assessor. He is also an active member of the SACPS as well as the SAIMM. At present, he is employed by Exxaro to lead process engineering on various mega projects. When not at work, Sipho enjoys spending time with his friends and with his family. Sipho, just before you start, I would like to mention to everybody that there is a Q&A function. So if you have questions for Sipho during his presentation, please type your question in the Q&A box. At the end of the presentation, I will read the questions to Sipho and we'll give Sipho an opportunity to answer your questions at the end of the session. So I now hand you over to Sipho Gerald Sikhosana. Sipho, your presentation is going live. Presentation is live.
Thank you very much, Jason. I'd also like to say thank you to Deborah Reddy, the chairman of the SACPS, the SACPS committee, as well as the members for lending me the ear today. Those who were present during the presentation that I gave last year, January, would remember that I presented on the design side of things. So the presentation for today, it's basically an update of the journey that we've gone through thus far. First of all, before we get to the business of the day, I would actually like to recognize all the partners that have participated within this project, as well as the ops team. That includes the contractors as well. Up to today, we have had no LTI. I think it's over 3 years now since we started. I think that is commendable. It's very unusual, but that's what the industry must strive to actually achieve. So with that, I'd like to congratulate them and recognize them for that. Now, we had our first coal last year in September. 2 weeks down the line, we were able to reach nameplate capacity within the plant. And a month later, we were able to actually do an operational handover of the Belfast Coal plant. So with that, there was quite a few learnings that we had to go through, because it was basically completely new for Exxaro to produce RB1 from this Belfast area. We've had previously our other operations, but it was not for RB1. Now that came with a whole lot of challenges that I am actually planning to share today. I must say it was quite tricky to prepare a presentation for the SACPS, because the Belfast plant is basically a cyclone plant, and I am pretty sure that all coal process engineers know exactly how a cyclone works, but they might not know how it operates or what's the performance within the Belfast area, because I'd like to believe that the Belfast coal mine is the first RB1 production mine within the Belfast area, not unless I can be proven otherwise. Now, for those that were not in the presentation last year, I'll go through the background so that you can actually relate when we go into the details of the presentation. So with that, it will cover the resource qualities, the production, markets, and logistics. From there, I'll have a high-level talk on the coal handling processing plant flow design. And with that, we will get into the ROM characteristics. From there, we will go into the DMS plant, also called heavy medium plant, and also talk about the RB1 product sensitivity. The screen that's up, it shows the resource qualities. You would see that our SIM2 makes about 90% of the resource. And its in situ quality, it's sitting at about plus minus 25 megajoules per kilogram. So if you ask me, if that is nice and dry, it's almost a B grade quality, or RB2. Then the rest is the SIM3 and SIM4, which SIM3 in situ is almost ESCOM quality. And SIM3 will definitely need to be watched to actually make ESCOM quality. The plant so far has only beneficiated SIM2. The life of mine of this current plant is about 16 years to treat 3 million tons per annum of ROM. And with the SIM2, it will be a double stage, or it is a double stage to produce a minimum of a 5850, which we typically know it as a 6,000 kilocal per kilogram. Then the sinks from the first stage is reprocessed to produce middlings, which in our case is the 4,800 kilocals. Both products are being exported. Now, when we see SIM3 in future, the intent for that SIM it would be to produce just the middlings. We have also currently built a new linear siding, which is about 30 kilometers from where the Belfast mine is. That's where we load trains to rail them to the RBCT. Now, going on to the plant, we basically have designed the plant to receive about 1.2 meters top size for ROM, which goes through a crushing and screening section. It's an open circuit type design where we produce minus 80 millimeters at 750 tons per hour. With that, we feed it into our buffer capacities of 2 silos, each about 7,500. And from the silos, we control our feed to a maximum of about 500 tons per hour, which is fed into the low gravity dense medium or heavy medium circuit, where we screen out the -1, which goes into the fine section. But for now, let me touch base on the +1. The +1 is pump fed to a 1300 dense medium cyclone, where the floats from that cyclone is your part of your export product quality, which is the cost side of the export. Since it's sitting at -80 millimeters, we recrush it to -50 to produce export from the low gravity. Then the sinks from the low gravity cyclone, it is fed into the high gravity plant where we produce the middlings. And the sinks of the high gravity plant, that is our discard. The floats, we also crush that to -80 for top size control, to -50, sorry, for top size control for the middlings product. Now moving on to the -1, that is also pump fed into the fines DMS plant, where we deslime the -150 microns into our thickening system, filtration. Then you can either blend the filter cake to the RB1 product quality to achieve the RB1 product quality, or you could send it to a filter cake stockpile. That was the main selling point for the design, that we'll be able to blend all of our filter cake into the RB1 product. I'm rephrasing that because I think I'm going to speak a bit lengthy on that, because that has proved to teach us a few things. Now, the -1 millimeter to 150 microns, that is beneficiated with the fines DMS plant, where the rougher cyclone takes out the discard, then the cleaner cyclone splits out the export material, then and the middlings material, which are both blended into their respective streams. Now, you would see that I have a lot of red on this slide, because I am definitely going to talk about ROM, touch base as well on the low gravity, spend some time on the fines DMS, and as well as the export product with the filter cake. Just for understanding, this is our typical PSD, which goes into the respective streams. And for an idea as well, our design envelope for SIM 2 to SIM 4 is between 50 and 90%. So it's quite a wide envelope. Now, moving on, the picture that you see here is a picture taken from the tip bin, where we receive the raw material. It's the tip bin, then next to the tip bin is the primary sizer, where we crush to -250. Then the next station that you see there, there's a screen where we separate the -80 to bypass the secondary sizer. Then when everything is all -80, it is conveyed to the silos that you can see from a distance. So basically, that's what it is. Maybe someone is asking themselves, why do we really want to talk about the ROM? I must say, if you are trying to produce RB1 from the Belfast area where we're currently mining, and you sleep, you will definitely miss the spec. The ROM from this area, it is not forgiving at all. You know, in other mines, they've got the luxury of blending pits and blocks from different areas. But in our case, if you're going to do that, you need to be very, very, very careful. I've got this slide up to also take you back as to where do we come from with this design. when we started the project, we had slim core data, which we use for our financial modeling and as the basis for our PFS, as well as the BFS. But before we concluded the BFS, we had to do a bit of sampling to further understand how the fragmentation of the material is going to look like, and to also firm up the design that was at the table at the time. So what we have here is data that was extracted from the large diameter drill cores. You would see that the curves are basically on top of each other. Now, from that scenario, it actually was able to confirm that it is okay to process your minus 80 to 1 millimeter in one vessel, of which that's how our design is. And also the characteristics of the coarse material was also assumed to be the same as that of the finer material, because that's what we've seen. We've also further went into our next door neighbor mine, which was operational at the time, on Verdag. We got a bulk sample, and the very same scenario was realized. The other point that I want to bring from this slide is that if you want to produce A grade, you are typically cutting at a density of about 1.55 to 1.5. But now, if you go slightly lower to just below 5, you would see how steep the curves are, and that talks to the near density material of this ROM. In the past, we've assumed it to have a maximum of about 45%, but we had a nice surprise since we started running. The near density issue is only an issue if you want to produce the A grade material, but if you want to produce the B grade or RB2, you'd see that the curve is very flat. So when you move away from RB1 to RB2, your near density issue disappears. Now, the slide that I have up now is data that was extracted from the plant feed qualities. The thin black curves that represents your geological data. The red dotted line, it's your cost fraction of the ROM. Then the green dotted line represents your fines fraction of the ROM. You would see now that if you had made an assumption that your fines will behave as the cost, you are actually completely wrong. So now that calls for more work. It means that your fines cut point cannot be the same as your cost cut point. We're lucky enough that the cost fraction is talking to the geodata, and for the fact that it's slightly lower than the geodata, that talks to your geolosses, mining dilution, and contamination, because I mean, life can't just be perfect, but it at least talks to the geodata. So if you were only treating the cost fraction of the ROM, you would perhaps maybe discount by 10%, roughly, plus minus, and life can continue. But you can't do that for the fines. So you would see that for us to make RB1, on the cost side, we'll have to cut at 1.5, but on the fines, we'll have to cut at 1.55. So that's just one point that I'd like us to recognize here. So how do we deal with this? We had to relook at our pit analysis regimes. So what we do now, we occasionally or strategically pick specific samples within the pit where we crush them to minus 80 millimeters to produce the PSD. And with that, we will do fractional washabilities as per the size splits of the plant, which is your minus 80 to 1, minus 1 to 150 microns, and your minus 150 microns. The top coarser fractions, we would do fractional washabilities. for the slimes, we would just do approximate analysis. Now, again, once you have this information, you would have to make a decision as to what do you do with the slimes, what is your predicted cut point, and what yield should you be expecting. I understand that in other mines, the geo model or the geo data is adequate to actually make those calls, but in our case, not so much. So it's actually also not recommended that you blend different blocks and different pits. So it's actually a strictly batch process, not unless there is similarities to those 2 pits or 3 pits that you want to blend. So if it happens that you actually under pressure for production and you've got those blends that don't talk to each other, the decision will be yours. You could make your tonnage to plant, but you might not make your yield, and your misplacement might really be elevated to levels that you don't want. So after the sampling and the analysis of the pit phase where we would be mining at the time, we would use that to predict what a total yield should we achieve in the plant. We have in-house developed an MRM tool where we'll take those specific splits and plug them into the data input tab. And with that, we are able to spew out for each plant where to cut, and also have a proper guidance on what to do with the filter cake. Speaking of the filter cake, during the design, well, it was an informed decision as well from all the sampling that we've done. We made a call that the filter cake quality or the slimes will have the same qualities as the raw material, but we were proved otherwise. You see the curves that I have up from this year, January until April. The green curve shows your RAM quality, and the bars actually simulates your filter cake qualities. So it's evident that more than 90% of the time, the filter cake material, it's not the same as your ROM. It varies by 2 to 3 megajoules per kilogram from what your ROM would be. With that, it actually makes it difficult for the times when your filter cake is extremely poor when compared to the ROM to be reblended into the RB1 and make spec comfortably. So with the MRM tool, we are able to determine what to do with the filter cake. Within our design, we had designed to blend it onto the export, which is the RB1, or to throw it out as a standalone into our filter cake stockpile. What we're currently doing there, we mostly throwing our filter cake into the stockpile and selling it as a standalone. But there are times where the filter cake is close enough to be blended to the RB1, of which that is the first case, or what we would like to have an ideal condition. Again, I made a point earlier that we have high near density material. We're expecting an average of about 40, but we are seeing peaks that goes up to 70. What I have on the screen, the top portion on the left, you have your net density percentage, and then on the x-axis, those codes, they represents the blocks that we are mining. Then the red line shows the average that we have expected, and then the dots shows the peaks that we see. You would see from the top graph that your near density average is more above the 40. But when on the bottom graph, you see that we actually have slightly less when we're not blending the filter cake. But when we're blending the filter cake, we're seeing more. And the reason for that is because if you want to blend the filter cake, you will need to wash slightly sweeter. That is moving away from your 1.5 going to perhaps maybe 1.75. And that's where the washability curve is the steepest. And that's where you see your 70%. But now, if you don't want to blend the filter cake, what happens is it allows you to wash at slightly higher cut points, and with that, you avoid the near density region. To put that into numbers as to what does it mean, I've got this table that I've put up here. It's basically the average of the life of mine for when you blend the filter cake and when you do not blend the filter cake. You'd see that if you blend the filter cake, initially we thought that the filter cake will have a positive contribution to your RB1 yield, but actually that is not the case. If you do not blend your filter cake, the yield gain on RB1 from avoiding the near density zone is actually 10% more. So it's really not worth it to blend the filter cake onto the RB1. And it also does not just improve the yield, it also improves your organic efficiencies as well. And you are able to wash slightly rougher, not as sweet as you would have if you wanted to blend the filter cake. You would also see that that is also shown within the weighted average DMS CV. You see, with filter cake, you have to be sitting at about 27.4, but without the filter cake, you can actually wash slightly rougher and get a very good yield upside. So that's basically what we're doing currently. So you would ask yourself now that we're planning to sell the filter cake at RB1. Obviously, I think it's known in the industry that if you're going to sell it as a standalone, you're not going to make that much money. But the yield upside on the RB1, when you do not blend the filter cake, actually justifies that you should not do that. In fact, you should consider blending it either with your RB3 or your 4.8 material if you have that opportunity. Now, this near density is a definite pain. So what we've done during the design phase, we've allowed for a barrel within the cyclone, and we also opted for a large diameter cyclone because it's very forgiving if you want to achieve high medium to coal ratios. And again, it also allows you to have a slightly bigger spigot for a case where you have higher percentage of sinks, then you don't have spigot loading. Then what we've also allowed in the medium circuit is high medium to ore ratios. And also, which is actually extremely important in our case, is to achieve high cyclone feed pressures. So with that, on the low gravity, we've allowed for up to 12D, and for the fines, we've allowed for up to 9D. What we've picked up is that if your pressure goes down to below 165, which is our normal wheat bank pressure range when we say we're running at high pressures, which is typically 90, the misplacement that you see there is extremely high, and it just doesn't justify you running the plant like that. So we are definitely running our plant at 12D at all times, not unless we have prior information that we are not we won't be receiving material with high near density. Then what we do in those events, we would drop it to about 170 kPa without actually experiencing any misplacement. But that is only if you're not putting material of high near density material. And that also assists with the life of your equipment, because high pressures, they definitely compromise the life of your cyclones and your pump as well. And again, on the fines at DMS, we've also seen that within the design, we've allowed for up to 2040, but we've picked it up during commissioning that when you pump to very high pressures, your cyclones does not only cut at density, it also cut according to size as well. So we are more safe when we're in lower pressures. And as well, as you've seen on the fractional washability curves that I've shared earlier, your fine curves are less steep as compared to the cost fraction of the coal. Now, the other thing that we do is the medium to ore ratio. We've interlocked our tanks to 30%. If it goes below 30%, we actually want to trip the feed, because when that happens, then you don't have enough medium to achieve the medium to ore ratios as stipulated on the bullet below of about 4.2 for the low gravity and 6.7 for the fines DMS. So our operating philosophy is to ensure that all our CM tanks are always above 50%, so that we have that cushion should it happen that we see near density material. We are not compromised when it comes to the medium to ore ratios. Now, another thing about the ROM, I have 4 samples on the slide. Just want to show the variation. All these samples were blasted by the same blasting spec. But if you look at the variation, it is quite huge. So with that being said, the reserve cannot be blasted with the one size fit all. There is pockets which are hard enough and they deserve a decent charge, and there is other pockets which can be freed up. So you need to know where you are within the reserves, or otherwise you're going to send powder to the plant. Our mining colleagues, I know they're working extensively on this issue to optimize and to fully understand our reserve and make sure that we at least consistently see material which is similar to sample 4. Now, why is this the issue? The low gravity cyclone, its breakaway size is about 7 to 10 millimeters. Now, if you look at the +1 to -10, if you're going to see about 40%, then you're definitely not going to win. So it is extremely important that the coal that comes into the plant is not powder. With that, the fragmentation variation must be understood. So whoever that needs to invest in the area to produce RB1 will need to pay attention on how the blasting will be conducted, because the fragmentation varies a lot. The other issue that we've picked up in the area is that we have weathered material. There is pockets of weathered coal. So when we see that there's poor flocculation, then you get black water, there's increased fines content resulting in high magnetite losses, and also RB1 product misplacement. Then with that, because it's fines, fines ends up into the filter cake, then you have an increased tonnage of the filter cake, and your moisture content really goes south. You get a filter cake which is not really a cake, it looks like toothpaste. Over and above that, your water pH actually also gets lower, then it becomes acidic, and you also have increased probability of blockages on key shoots. Of course, the blockage means the plant is not running. So it is very important that there is a clear communication between the plant colleagues and the mining colleagues and geology, so that when we receive weathered material, we know beforehand, so that within the plant we are able to trickle feed it and blend it with similar type coal in terms of your cut points, and avoid having all these issues that I've just listed. For the poor flocculation, we had to now investigate coagulants. We're actually using coagulants now then when we are treating weathered material. We also have a liming plant to pay attention to the pH, because I think we all know what happens there. And if we have an increased moisture on the filter cake, what we do, we allow that stockpile to further dry, so that at least when you take it away, it's at a decent moisture. Moving on to the dense medium separation. Not going to be very long on this one, because I think we all understand cyclone. I just wanted to share the efficiencies. This picture that I have here was taken towards the tail end of construction. I also just wanted to show that from the silo, how is the plant laid out? You could see we've got 3 buildings, LG, high gravity, with a sedge bin in between, and the fines DMS, thickening, and the filtration circuit. The split, again, if you want to put it into tons per hour, for the low gravity is about 420 tons per hour, fines about 50, slimes about 30 tons per hour. The graph that I have here is the efficiency curve for the LG DMS cyclone. You'd see that we are able to achieve a 0.02 when we actually not blending the filter cake. When you blend the filter cake, that EPM also gets compromised. If you go to the fines DMS plant, we are able to achieve a cut point of about 1.8 for the Rafa cyclone with an EPM of about 0.06. On the cleaner, we are able to achieve a cut point of about 1.5 to split our RB1 product from the middlings. Some learnings from the fines DMS, because it's a technology that's been there for many years, but it's not popular because of the magnetite losses that were high in the past. What we found with our design is that with the new generation MACSAPS, that issue has been sorted out. The magnetite consumption is actually very reasonable and is competitive with the other technologies that don't use magnetite. But for that plant to perform efficiently, you need to ensure that your desliming of the feed to the fines DMS plant is in check. That is very important, because if it's not, then you're going to have ultra fines into the fines DMS plant and they will interfere with your medium stability. Then you're going to get misplacement. So that is why earlier as well, when I was speaking about the ROM, I mentioned that we don't like the fines because it just gives us problem everywhere. And if you don't pay attention, then you'll have fines. Then you will actually see flames. The other lesson that we've learned, when we did the design, we sort of had same size MACSAPS for the discard middlings and the RB1 MACSAPS. So, because we have very high yields occasionally, so what happens, your RB1 MACSAPS gets overloaded. We could have been better off if we were one size up with that MACSAPS. But what we've done, we've installed an additional water dilution to protect the overflow from the other MACSAPS when there's high yield, because most of the flow would go to the other MACSAPS to protect that. And for where the MACSAP is overloaded, to protect the MACSAPS from entrapment of the non-MAX, because that would sit under the drum and some of it actually goes into the concentrate or the overdense. So what we've learned is when your overdense is full of nutmegs, then your medium stability basically doesn't exist. Then your cyclone sort of becomes a splitter. So what we are doing to sort out that issue, over time, say once a week, we drain our CM tank of the fines DMS plant and put in fresh medium. Then what we have drained, we don't check it out, we send it to the cost side of the plant, because at least there we've got densifiers. We can remove the non-max from the medium and reuse the medium within the cost section of the plant. What we've achieved with the fines DMS, I must say, I was slightly worried, because wherever I went, people would ask me if I'm confident about this fines DMS during the design phase. I'm happy to announce that it was actually the right decision that we've taken to go with this technology, because it is able to do low cut points at very high net density material. We've actually recently done a test work campaign to compare the fines DMS with the new LC3 spirals. The fine CMS still came out tops. But it is specifically for this case when you're producing RB1. But if you're going to produce RB2, then the spirals was going to come top, because there you are not sitting in the high net density material. So other thing is, since we've got high net density material, the cut point control is also critical. With the fine DMS, you are actually able to accurately control the cut point and minimize misplacement, which is something that we do not want. And the cut point density as well is approximately about 0.2 to 0.2 units higher than the circulating medium. What we're using for the fine DMS is the 85% minus 45 micron magnetite, and we found that to work well. Our current magnetite consumption is about 1.5 kilograms per feet ton. Still room for improvement there, but I'm happy to say this is within range and is within the design envelope. But there's one or two things that we're looking at into improving the magnetite consumption as well. Now, I also want to talk very briefly about the RB1 product sensitivity. You see what I've circulated with the red. It's sitting at about 8.7% moisture. That was a tray which the quality was 5873 kilocal. What I want to bring attention to with this is that if that moisture was 9%, regardless of the ash content being 13%, the train was going to fail. You know, the Belfast area is not usual, I must say. Some know the weather this side. I think the weather has always been the case from the past, because I have not seen any coal that has inherent moisture that peaks at 5%. Unfortunately, this area, our coal peaks at 5%, and there is not much room left for surface moisture. I mean, to stay below 9%, it means you have about 3.5 to work with, and that is very, very, very small. So take note of that. The inherent moisture is very high. So that means our de-watering is as important as our beneficiation, because you could be a rock star on the beneficiation side of things, but if you're not going to de-water the product properly, you might not make a spec on the train, just purely on moisture. That's how sensitive the material is this side. Again, sampling and analysis accuracy, equipment accuracy is also extremely important, because if there's errors from the sampling, then when you get your data from RBCT, they will definitely tell you that, look, you can't invoice that train as RB1, you'll have to invoice it as RB2 because you had errors within the sampling. So we pay attention to that. And the rain, that is just one thing which we are at the mercy of the Most High with the rain. So what happens is that you would produce at your optimal yields, and your dewatering equipment would be optimized. Then you'll have an inspect product on the stockpile. But just before train loading, then it rains. Let me tell you now, when that happens, you will definitely invoice that train as an RB2 when you've produced it as an RB1. This is actually the first area where I've been exposed to where if you're going to produce, you'll have to pay attention to the weather forecast. So what we do is, if we know that there's going to be rain and we don't have fresh stock, we would produce slightly sweeter so that when you get that rainwater, you are still within the spec and you can at least pass your train, because it is very heartbreaking for all this effort that when you're at the finish line where you have to invoice your train, you can't invoice it as per your intent. So that's how we work against that issue. And again, since we are a two-product mine, if it happens that a middling truck by mistake, because maybe the truck driver was tired or for whatever reason, he offloads it on an area where it's a RB1 area, that could make that train which will be loaded with that material for RB1 fail. And when I fail, I say, it can only be invoiced as the RB2. Now, again, the filter cake also exacerbates the RB1 product quality sensitivity. So how we go around this, whenever we have an opportunity, we prioritize loading dry stockpiles where possible, because we know our coal is extremely sensitive to moisture. Just some highlights at the tail end of this presentation. Just to remind you, something that we pride ourselves with is that we use the same ROM overland conveyor to return the discard into the discard area. So we call it a dual carry conveyor. We've commissioned that, and it has been working very, very, very well. So we pride ourselves with that. The advantages of that are obvious. Reduction of discard hauling truck fleet, diesel, and footprint and distances as well. We're also using the sizing technology, the latest, which is semi-mobile. Once we've advanced within the mining area, we'll be able to extend our conveyor to closer to where we'll be mining. And again, even on that, the benefits are obvious. The last point is the fines DMS. We've got one at Lopan, but it's currently not operating. We're using spirals. This is the only one which is fully integrated into the plant. So if the fines DMS is not running, the plant cannot run. And with that, we're actually very happy to report back that the fines DMS within the Belfast area is a success, provided you pay attention to the raw material. Only then you'll be able to make your product. And with that, I'd like to conclude this presentation. I think that's my time. Decided to put this nice painting of our area. So now I'll hand over to Jason and to address any questions if there's any. Jason, take it away, sir.
Sipho, thank you very much. That was a very comprehensive and very insightful presentation, and thank you for sharing the information about your project with us. Sipho, we have a couple of questions here for you. So I'll start with the first question. How long was construction? Basically from start of construction up until first production.
Thank you, Jason. I think it was about, so you say from start of construction to?
Start of construction to your first coal, yeah.
Okay. I think that was about plus minus 16 months. I don't know it from top of my head. It's been long, but it's plus minus 16 months.
Okay, excellent. Sipho, one more question. I'm just getting to that right now. A question from Anonymous. The coal industry has always struggled with fines DMS processing. What lessons were taken from the historical experience to get it right at Belfast?
Okay, thank you for that question, Jason. I think it's the obvious. The only reason that the fines DMS was not working out, it was because of the high magnetite consumption. Once the new generation SACPS was introduced, we were able to solve that issue by improving on the magnetite recovery. And only now we're actually able to run that plant with very low OPEX and realize the end goal. That was the main lessons learned from the past. Without the SACPS, it's definitely not a winner. So the SACPS actually enabled this technology to be used for fine coal processing. Thank you.
Excellent. Thank you, Sipho. I think just a comment from Anonymous. Very good presentation, Sipho. Congratulations to you and your team and partners in delivering such a project successfully and safely. And thanks for sharing the operational experience and lessons learned. Thank you very much for that comment. Sipho, moving on to the next question, a question from Chris Swanepoel. Thanks, Sipho. Very good presentation. A number of questions. Am I right that a separate plant will treat the 3 and 4 seam in future? Are you experiencing higher wear with the 12D pressure on the coarse plant? With weathered coal and the impact on water quality, have you included a water treatment plant? Have you included water treatment, and what are you treating the water with? Can you expand on the type of sizing station and how you will control the fines? So there's 4-in-1 questions there from Chris. Do you mind? You can take your time with that.
I don't mind at all. The first one, please run them one by one, Jason.
So the first question is, will there be a separate plant to treat the 3 and the 4 seam in future?
No, not at all. When we hit the SIM 3 and SIM 4, we will only use the low gravity plant and the fines DMS and shut down the high gravity plant, because with the SIM 3 and SIM 4, it's actually not a double stage requirement. So we've got a flopper system to divert the LG flows into the middling stream. So no, we have not actually done that. You remember again as well, SIM 3 and 4 combined, they make less than 10% of the resource. So that was not the driver for the design. We will use the current plant to process a SIM 3 and SIM 4. So that is also in the business plan. It's not going to catch us by surprise. What was the second one, Jason?
Second question, are you experiencing higher wear with a 12D pressure on the coarse plant?
Not very high on the LG side of things, I must say, which is actually something that I cannot explain at this moment. But where we're experiencing high wear is on the high gravity section of the plant. And that, when I think about it, we're still investigating that with the OEM. But when I think about it, is that even though we're not running that at 12D, we're actually running that at 9D. But the rocks, which are sinks from the low gravity, they don't have the cushion, which is your sweet coal that is your RP1 that floats on the LG. So with those rocks, then the wear on the high gravity cyclone, which is a 1 meter diameter cyclone, is very high. If I can put some numbers to it or durations to it, there was a point where cyclone lasted us only 3 months, and by industry standards, that is not acceptable. So we are looking at solving that problem. We're looking at different type of material, specifically for where that localized wear is happening on the high gravity cyclone. But on the low gravity cyclone, we're actually getting very good performance, which is slightly weird because that's where we're doing this high pressure, the 12D that I mentioned earlier. But the wear on that cyclone is not very, very high as compared to the high gravity. Thank you, Jason. If you proceed to the last one. Yes?
The water treatment with the weathered coal and the impact on the water quality, have you included water treatment, and what are you using to treat the water with?
Not a water treatment plant. What we have is a liming plant. We basically dose lime into the system to just control that pH, and when the pH is fine, then all is well. And it's not all the time. I'd say the occurrence is about less than 10% of the time. So it's not all the time. And how we actually also control it, we try and not find ourselves in a position where the acidity is very low. So we have pH meters within our water circuits with alarms to actually tell us before things get out of hand that the pH is dropping. Then we respond to it and we also look at what's coming into the plant, and we make sure that we dilute it with good quality coal so that we do not have to use a lot of limestone to actually control the pH. But at this moment, we don't have a water treatment plant. There is plans in future to have a water treatment plant, but it's not because of this acidity. This area has got a lot of rain. There is just too much water. So that water treatment plant, it will be for the case where we want to release water to the environment. We'll have to treat it and make sure that it's safe and it's not harmful to the environment when we get to that position. But at this moment, we are not there yet. But there is plans to do a small water treatment plant in the future. Thank you.
Excellent. Excellent. Thank you, Sipho. To the audience, Sipho has committed to log all the questions and come back to all the individuals after the session. I think for the sake of time, as we're running out of time now, we will record it and Sipho will then get back to you at the end. I will just run through a couple of comments before we conclude very, very quickly. Sipho, comment from Lucy. Job well done, Sipho. You've packed our story very nice. Well done. Comment from Mesh. Excellent work. Will the presentation be available? Yes, Mesh, the presentation will be available on the SACPS website. Johan Nieber, thank you, Sipho. Very insightful presentation. One question. If you had to redesign the plant, what would you change?
I'd like to answer that.
Okay.
Yeah, if I had to redesign the plant, I would try and if the numbers make sense, I would actually have a loadout system nearby, a rapid loadout system to be specific, such that when you produce the material, you are able to directly send it onto a train, and either with a silo or a reinforced earth bunker system that is fully covered and away from the rain. That's what I would actually bring forth into the table. But as for the crushing circuit and the DMS, I wouldn't really change much because we are doing work to solve the fines challenges that we occasionally experience. But if that cannot be sorted out, what I would do, provided that numbers make sense as well, I would at least maybe try and split the plus 25 to 80 into one vessel and the minus 25 to 1 into a separate vessel to minimize the breakaway impact that we occasionally see when there's high fines. Those would be the 2-3 things that I would do differently if we had the opportunity. But we are very satisfied with the performance that we've achieved so far within Belfast in terms of efficiencies. I mean, you've seen the LG is definitely sitting at 0.02. I think that is very commendable. And that was what was promised by the OEM. So we were glad that we have achieved that. And the fines DMS, we're sitting with the RAFA at 0.06 EPM, the cleaner 0.07, which is well within the literature range. So we're very pleased with that. Thank you.
Sipho, thank you very much for your presentation today. Thank you very much for answering the questions, and also I would thank you in advance for getting back to all the questions that is still pending. All the questions are relevant, and Sipho will get back to everyone that has asked questions. Sipho, again, thanks from the SACPS. We will courier your 50th anniversary book, as what we do with all our presenters, as a token of gratitude for you. To everyone, to the audience listening in today, our next session will be in September. The exact date and the topic will be announced in due course, and we will most definitely do it in the same way. And I think in the next round we'll see if we can make a little bit more time for Q&A at the end. But thank you very much for tuning in today, and we certainly hope that everyone remains mentally and physically well, and stay safe out there. Thank you very much, and have a blessed day.